So we are on page 190 of topic 6, transformations of exponential functions. So basically what a transformation is you are essentially having one graph that shifts down, or it can shift up, or it can shift to the left, or shift to the right. Okay? So that's essentially what a transformation is. It's your main graph and how it shifts either to the right, to the left, up, or down. Okay? So consider the following exponential function. F of x equals 2 to the power of x. And below is the graph. So this is the graph for that function. Okay? This graph right here that we see is going to be what we use for our transformation. So you're going to start to see, how does this graph shift to the right, to the left, up, or down? Okay, so let's see. Let's move on to page 190. Okay, consider the following transformation. F of x. Write a function to represent each transformation function and describe the transformation. So basically what this is asking is, what is the difference between this graph right here, okay, and this graph right here? So what changed? Well, clearly the graph flipped, right? We can see that the graph went upside down. And look right here, there's a what right there? Well, there's a negative. So because of that negative, this means that the graph, okay, the graph reflected, and what reflected means is it just flipped, reflected the x-axis. So again, all that it did was it essentially went from here and it flipped the x-axis. All right. So because of that, you have a negative f of x, and all that I did was I grabbed this from here. Okay. Now, what number were we using at the top? Well, we were using a 2 to the power of x. So because of that, and because the graph flipped, it will only flip if you have a negative in the front. So all that we did, the transformation was adding a negative. And when you add a negative, the graph flips. Okay? When you add a negative, the graph flips. Okay? All right, let's move on to this one. This one says f of x plus 3 in parentheses, inside the parentheses. Okay? So first off, what I'm going to be looking at, let's go ahead and let's look at this point right here. This point is 1, 1. Or 0, 1, sorry, 0 and 1. So that point, go ahead and put that on the graph. 0 and 1 is right here. Okay, so what happens to the graph? So this dot moves 1, 2, and 3 to the left. So moves 3 to the left. Now look at right here. We added 3 to this. So when I add 3, the graph shifts. And where does it shift? Well, it shifts to the left 3 times. Okay? So whenever we have a inside parentheses, a plus 3 or a plus anything, it's going to move to the left. So all that I'm going to do is f of x plus 3. Again, all I did was I grabbed that from there. The original function was 2 to the power of x. But what did we do? Well, it shifted to the left, so I'm going to add 3 to that. Okay? So again, if I add in parentheses, it's going to shift to the left. All right, let's move on to the next one. F of x minus 3. So once again, we're going to use that point of 1, 0, and 1. Now this is minus 3, and guess what happens? It moves 1, 2, 3 points to the right. So very similar to the other one. The other one we added 3 and it moved to the left. This one we subtract 3 and the graph shifts to the right. How many times? Well, it shifts to the right 3 times. Okay, so whenever I add, I'm going to move it to the left. Whenever I subtract, it moves to the right. So this becomes f of x minus 3. So again, got that from there. And now the original one was 2 to the power of x, but this time, all I'm going to do is minus the 3 at the top. So when you minus 3 in parentheses, it shifts it to the left. Okay, now let's recognize what happens if I put it outside of parentheses. Okay, so look at this one. This one's outside of parentheses. This one up here was inside parentheses. So when it was inside, it shifted to the right. Now what happens if it's outside? So once again, let's do that point, 1 and 0 and 1. And let's see where does it go? Well, it goes down 1, 2, 3 times. Okay, and since it shifts down, that means the graph shifts down 3 times. Okay, so when it's outside of parentheses, the graph moves down. So this becomes f of x minus 3, and that equals 2 to the power of x minus 3. So notice the difference between this one and this one up here. Up here I had this, and down here, I put it not as an exponent. Okay? So right here, put it as an exponent if it's inside parentheses. If it's outside parentheses, do not put it as an exponent. Okay? All right, let's move on to the next one. This is f of x plus 3, but the plus 3 is outside of parentheses. So I think you guys are starting to hopefully understand this. If it's outside parentheses and it's adding, it's going to move up 1, 2, and 3 times. So up 3 times. So the graph shifts up 3 times. Okay, so once again, we're going to write this as f of x plus 3. And it's going to equal, well, the original one, 2 to the power of x plus 3 on the outside. Okay. Now, let's look at the next one right here. Next one is 3. 3 times f of x. Okay, so 3 times the f of x. So this one, we're going to look at that 0 and 1. And we're going to see what happens. Well, it shifts down 2. But let's see what the original one looked like again. The original graph, you see how small that graph is? Okay, and look at this graph over here. Look at how much wider it is, and it's completely different. Okay, now this one's a little bit harder to understand, but the graph, when I multiply, the graph is vertically stretched. And don't worry too much of this. We will rarely see this happen. Okay, but if I wanted to write this, it would be 3 to the power of f of x. Remember, this is timesing it, which means if I wanted to do the same thing, it would be 2 to the power of x times that 3. Okay? All right. Let's move on to the practice. Okay? Describe how k affects the graph of a function f of x equals 2 to the power of x in each of the following situations. Assume k is greater than 1. So what this is asking is, what happens when I subtract it outside of parentheses? So what happened when I put it outside of parentheses? So look for that graph. What graph was it when I shifted it out of parentheses? So this is outside parentheses, but it's an addition one. This one is a inside parentheses addition. Perfect. This one is outside of parentheses, subtracted it. And what happened to my graph? Well, my graph shifted down 3 times. So if I wanted to, how many times would my graph shift? Well, my graph shifts down. Do I know what k is? I don't, but what we say in algebra is graph shifts down k units, because I don't know how many times it's going to go down because I don't know what k is yet. Okay, let's move on to the next one. B is f of x plus k, but this is a plus k inside of parentheses. So let's look for that graph. Okay, plus inside parentheses. This is outside of parentheses, inside parentheses. So the graph shifts to the left 3 times. So this one I'm going to say the graph shifts and we said to the left, and I don't know what k is, so I'm going to say to the left k units. All right. Now this one is the multiplication of it. So this one is going to be saying the graph, and remember we just did this one, is vertically stretched by k units. All right. Now the last part, number 2. The function g of x represents an exponential function. The ordered pair 6 and negative 3 lies on the graph of g of x. The function f of x equals g of x plus 5. Name a point on the graph f of x. So in this case, if I wanted to do this problem, I know that this ordered pair represents g of x. So that means this right here, whatever I input for this number, I need to input for that number as well. So if I say that f of x is, let's say I use negative 3, right? So what is negative 3? And all I'm going to do to that is add 5 to that. So if I want to know what f of 6 is, it's going to be g of x, which is, remember, g of x is the same thing. Whatever I put in here, I have to put in here. So this number right here is going to be the same as this number here. And we're using 6. So again, this number and this number are the same. And it's going to be plus 5. Okay? So according to the ordered pair says if you input 6, your answer is negative 3. So I just inputted 6. So my answer is negative 3 plus the 5. All right. So f of 6 equals negative 3 plus 5. And negative 3 plus 5 is 2. So what's the ordered pair? Well, the ordered pair is 6, positive 2. And there's your answer. Okay. So again, all that I did was I inputted 6 here. And then I figured out g of 6 is the same thing as this right here. G of 6 was negative 3. Negative 3 plus 5 is 2. Okay. The next one, the function h of x equals g parentheses 2x, name a point on the graph of h of x. So the only point we know is g of 6, and we know g of 6 is -3. Okay, so what would happen if I put g, how do I get, what multiplies to 6? Well, the only thing is 6 times 1, which we can't use, and 2 times 3. 2 times 3, that answer is -3. Because remember, this is the same thing as this. Where did I get the 2 from? The 2 came from here. The x, how would I get 2 times what gives me 6? 2 times 3 gives me 6. And that answer was -3. So that would mean, what was my input? What was my x? Well, I input h of 3. My input was 3. Okay? This number and this number match. So because they match, I have h of 3 here. So my ordered pair, the input was 3, my output was -3. Okay, that one was a little bit tricky, I understand, but the main focus is knowing what shifts and what doesn't shift. So what you need to do is you really need to focus on these parts right here. This, and all those other ones. Okay, complete the worksheet. I will be checking these and make sure that if you didn't get this, you're going to have to rewatch this video. Thank you.